Here's an example about maximum gas mileage. Most cars get their best gas mileage when traveling at a relatively modest speed. The gas mileage M for a certain new car is modeled by the function written right here. This is only good for speeds between 15 and 70 miles per hour, and it's measured in miles per gallon. What is the best gas mileage, and at what speed is it attained? So basically that's asking us to find the vertex. So let's find the vertex by our formula, negative b over 2a, negative 3 over 2 times negative 1 over 28. So that's negative 2 over 28. Since we're dividing fractions, we flip and multiply. So that's really negative 3 times 28 over 2. It'll be a negative 28 over 2. So it is a positive 3 times 14. So what that means is the best gas mileage happens at 42 miles per hour. So then to find out what the best gas mileage is, we need to plug in 42. So negative 1 over 28 times 42 squared plus 3 times 42 minus 31. That gets negative 63 plus 126 minus 31. Which is 32. So the best gas mileage is 32 miles per gallon. So 42 miles per hour is the speed at which best gas mileage is attained. And 32 miles per gallon is the best gas mileage. Our next example, finding local maxima and minima, those are just plural, from a graph. Find the local maximum and minimum values of the function x to the third minus 8x plus 1, correct to 3 decimals. So everything we've done dealt with quadratics. If it's a cubic or any higher power, we're going to use our calculator to make it easier. So we'll type the function in to our graphing calculator as y1. So x to the third minus 8x plus 1. And then before we graph it, just because I already know I looked ahead a little bit, let's go ahead and set our window to be negative 5 to 5 for our x's and negative 20 to 20 for our y's. You just figure those out by playing with it a little bit, figuring out the best viewing window. And this displays everything nicely. Since it's an x to the third, we know it should have this shape with 2 humps, a maximum and a minimum. So to find what the actual maximum and minimum values are, your calculator can do it for you, but you just need to give it all the information. So we need this calc function. So you need second to access the blue writing, calc. We are going to find a maximum Now it asks for a left bound and right bound. This is common for anything you're doing with a graph. So we're going to move to the left. Left bound just means point to the left, so the calculator doesn't need to try everything. It doesn't have eyes. You have to tell it where to look. So our maximum is definitely not as far left as our little cursor is right now, so that's a good left bound. Now a right bound. I've gone past it, so that would be a good right bound. And now a guess. I just want you to get as close as possible. And hit enter one more time. So there's our maximum. The maximum value is 9.709. And it occurs at negative 1.633. So we can put that in function notation. Now for the minimum, we're going to repeat those same steps. Second, calc. This time we're going to do minimum. You can either scroll down or just push 3 as a shortcut, since that's option 3. We need a left bound, so before we get to our minimum. That looks good. Now right bound, we need to go past it to the right. That'll do. And then our guess, get it where it appears to be. Press enter one final time. So our minimum is negative 7.709. And it occurs at 1.633. Now this way of using the calculator can work for any graph. It could be, you could even use it for a quadratic, but any graph at all you could do, calculate the maximum and minimum. You just have to tell it the left bound, right bound, and your guess. And it can calculate it for any function you want, so it's very useful.